James Webb Telescope just announced the clearest image of Proxima B seen in history. A mysterious planet has piqued the interest of scientists and space enthusiasts alike. James Webb Telescope just announced the clearest image of Proxima B seen in history. What secrets does this distant world hold? Can it support life? What is the James Webb Telescope? Let's have a look into what the James Webb Telescope just revealed. Looking back billions of years into the universe's history, we can glimpse how galaxies came into existence, and with the James Webb Space Telescope, or JWST, we can take that principle to the next level and explore the furthest reaches of space. The infrared images captured by the JWST are unlike anything human eyes have ever seen before, and the telescope's capabilities depend on how it's utilized. Much like a Snapchat filter on your phone, the James Webb Space Telescope enables astronomers to study the early universe and better understand the birth of galaxies, stars, and planets. Researchers can analyze the hues in those images by using the telescope's camera and filters to gather a specific range of light colors. The JWST will also investigate the atmospheres of planets outside our solar system and search for indications of extraterrestrial life. The JWST's ability to look further back in time and space than ever before has led to significant findings on the evolution of the cosmos. For example, astronomers use the telescope to discover more mass than previously believed to exist in the universe, hidden away in several massive galaxies. What is Proxima B? James Webb Telescope just announced the clearest image of Proxima B seen in history. In 2013, astronomers detected hints of a tiny gravitational tug exerted by a planet on its star. After years of searching, the planet, which orbits Proxima Centauri, was later named Proxima B. The discovery of this planet is fascinating since it orbits the closest star system to us after the Sun. Observing the Alpha Centauri system, which is around 4 light-years away from us, provides a glimpse into the past, since we are seeing it as it was 4 years ago. Proxima B certainly takes the cake when it comes to exciting astronomical discoveries. This planet is located a mere 4.25 light-years away from Earth, making it one of the closest exoplanets ever discovered. But don't let the distance fool you. Proxima B is a whole different world from our own. The planet is about 30% more massive than Earth, which means it's bigger too, but don't let that fool you. Proxima B's year only lasts 11.2 Earth days, which is super short. That's because the planet orbits its star, Proxima Centauri, at a distance of just 7.3 million kilometers, which is less than 5% of the distance between Earth and the Sun. You might be thinking that a planet that's so close to its star must be boiling hot, but Proxima Centauri is a tiny red dwarf star that doesn't radiate nearly as much energy as our Sun. So what would it be like to stand on the surface of Proxima B and gaze up at Proxima Centauri? The star would look like a dull red orb, roughly 3 times as big as our Sun. And if the planet is in its star's habitable zone, which it appears to be, it might have the right conditions to support liquid water. But before you start packing your bags for an interplanetary adventure, you should know that Proxima B is far from a second Earth. For one, the planet is likely tidally locked with its star, which means one side faces the star while the other is always in darkness. That's definitely not a comfortable environment for any potential life forms, and any water that comes too close to the star would be boiled away by its powerful radiation. On the other hand, if a planet is too far from its star, it won't receive enough heat, and all of its water will freeze. Proxima Centauri might not be as friendly to life as we thought. Despite having only a fraction of the Sun's mass, its small size causes its nuclear fusion core to be much closer to its surface, resulting in chaotic and turbulent surface activity. This activity leads to extremely powerful magnetic fields that produce high-energy radiation and particle bursts, posing a significant challenge for planets like Proxima B that orbit within the star's habitable zone. While scientists had some knowledge about the magnetic field conditions around nearby stars, they were in the dark about the precise conditions around Proxima Centauri until now. Thanks to a recent study using high-resolution magnetic field maps, we better understand the star's solar wind and the dire situation on Proxima B. The study revealed that the planet receives roughly 1,000 times more solar wind radiation than Earth, putting any potential life at risk from powerful flares. In fact, Proxima Centauri's flare in April 2021 was 100 times more potent than any flare ever observed from the Sun. It's hard to imagine life surviving such intense radiation without specialized shelter. While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality seems far from hospitable. As humans, we have always been fascinated with the possibility of encountering extraterrestrial life, and in late 2020, that fascination reached new heights when a peculiar signal was discovered originating from the Alpha Centauri system. Interestingly, this signal reads at an unusual frequency of 982.551 MHz. Encountering alien life may not be as far-fetched as once thought. The breakthrough initiatives have been researching the possibility of cutting down travel time from hundreds of years to just decades. Recent research highlights how current technology could potentially overcome the challenge of accelerating an object as its mass increases, particularly as it approaches the speed of light. Despite this, Alpha Centauri, being the closest star system to Earth, would still require around 6,000 years of travel time with current technology, making it a daunting journey. Starshot, a project aimed at reaching Alpha Centauri, is considering using lasers to propel a spacecraft toward its destination. However, the main challenge lies in the Earth's atmosphere, which affects incoming light and laser light, making it difficult to exert the necessary force to move a spacecraft forward. Bandy Tunga, the paper's first author, suggests that adaptive optics could be used in reverse to overcome this challenge. Small lasers on satellites would assess atmospheric effects in real time, allowing much more powerful lasers on the ground to maintain a tight focus on the space probe. The required lasers need a whopping 100 gigawatts of power to send the vessel at any given time, which is equivalent to the entire electricity consumption of the United States. However, the lasers only need to run at maximum capacity for 10 minutes to disperse the electricity across a 1-kilometer square region. They plan to use 100 million lasers. The Starshot team is determined to push the boundaries of space exploration. The object hurtling through space will be moving at an astonishing 20% of the speed of light when the lasers are turned off. This spacecraft would be a little over 10 meters in diameter and could reach Alpha Centauri in just 22 years. However, the gravitational pull of the Sun and interstellar debris may considerably slow it down. Even if the spacecraft reaches Alpha Centauri, its transmissions will take another 4 years to reach Earth. Bandy Tunga and his team know that keeping the probe from melting is one of the biggest challenges. To prevent this, the mirror on the spacecraft must be practically perfect, reflecting 99.99% of the light that strikes it. Additionally, it needs to double the momentum transfer while decreasing heat in a matter of days. Once launched, the probe would traverse the Alpha Centauri system, likely never getting very close to a planet. The fascinating part of this concept is that once the launch system is in place, more probes may be sent for a reasonable price. The chances of catching a fleeting glimpse of any Earth-like planets are significantly increased if a fleet of probes floods adjacent star systems. Imagine the possibilities. After arriving at Proxima Centauri, mankind would have an entire star system to explore. How many additional planets, like our own, might there be? Exoplanets are planets outside our solar system, and thousands have already been discovered. In 1992, scientists made the first official findings of planets circling a particular class of neutron star called a pulsar. 3 years later, the first planet revolving around a star similar to the Sun was found. Since then, numerous additional planets have been discovered, including several Earth-sized worlds within the habitable zones of their stars. If you've enjoyed this video, be sure to hit the subscribe button. Thanks to groundbreaking missions such as the James Webb Space Telescope, JWST, and the Kepler Space Observatory, and countless studies conducted from the ground, we've only scratched the surface of what we know about our universe, but it's a start. And if you're as fascinated by space exploration as we are, then you won't want to miss a single episode of Worldview Theory. So, while you're here, be sure to check out the video on your screen for more mind-blowing insights into the mysteries of the cosmos. Who knows what we'll discover next?